In this video, you'll learn how to check the accuracy of your forecasts and understand the predictive model components. In the previous video, you created a predictive scenario to forecast ozone pollution peaks over the next 12 months. Smart Predict has trained the model, and now it is over to you to analyze the results to see if you can trust the forecasts. The horizon-wide MAPE is the performance indicator. It gives you the average percentage of error made by your predictive model. The smaller the percentage, the more accurate your predictive model is. Your predictive model gets a horizon-wide MAPE of 16.53%, which is quite a good value. This overview report also gives you statistical information on the ozone rate and which model components Smart Predict has found by analyzing your data set. As you can see, Smart Predict has found that the long-term evolution of the signal will be a linear trend. No cycles have been detected, but there are fluctuations. These are indicated by AR37, which means that the previous 37 time series have an impact on the actual values found by the predictive model. Let's have a look at the forecast report. With the forecast versus actual graph, you can quickly determine if the predictions will be accurate or not. The graph initially shows you the forecasted and actual values from the data set. The predictions are displayed at the end of the graph. You will notice that we have predictions very similar to the actual values, and they fit nicely into the minimum and maximum error limits. For each forecasted value, the predictive model shows an estimate of the minimum and maximum error. This is called the confidence interval. In the tables below the graph, you'll find statistics on the forecasts and outliers. Identifying these outliers is easily done. The outliers don't disturb the forecast, as this is based on the model components. The last report displays visual representations of the model components. The trend curve is linear and decreasing over the years. The lagged predictor's contribution graph identifies if the ozone rate is influenced by observed values in the recent or distant past. It also gives the most important dates as well. The lags are numbered with negative integers that represent how far back in the past they are from the forecast. Earlier, we saw that Smart Predict found that the previous 37 time series have an impact on the actual values. This is why the graph stops at 37. Using these lags, you can analyze how the previous values influence the actual ones. Here you see that the lags -1, -29, and -36 are very influential. Using this information, you can understand the historical data of the ozone rates, and you can now forecast the ozone peaks for the next 12 months. To see more on Smart Predict or SAP Analytics Cloud, check out the SAP Analytics channel on YouTube or visit our SAP Help Portal site.